This video introduces two products manufactured by BBE Moldenke. The German company specialized in the field of biomonitoring and environmental control. It is most important to detect harmful compounds during the first stages of their appearance in water, so as to protect the health of human beings. Due to continuous pollution, the monitoring of water quality is becoming very necessary, as the life and health of every organism depends on water. The first instrument we will present is the new BBE DaphniaToximter. The DaphniaToximter continuously monitors water quality through the observation of living Daphnia, tiny water fleas, exposed to running sample water. What makes the DaphniaToximter a superior instrument in biomonitoring is its precision during online operation. The Daphnia react very sensitively even to extremely low quantities of harmful substances in water, for example pesticides, organic compounds or harmful salts. That is because these substances lead to alterations in swimming behavior of the Daphnia. The DaphniaToximter includes the following main technical parts. Firstly, measuring chamber containing the Daphnia. Secondly, observing camera system, CCD camera. Thirdly, PC screen and keyboard with integrated mouse. Fourthly, algae fermenter for feeding the Daphnia. Fifthly, cross-flow filter against blockage of the chamber tubes. The integrated PC analyzes different parameters of the Daphnia: speed measurement, altitude of swimming Daphnia, distance between Daphnia, size of Daphnia, number of active Daphnia. Fractal dimension is the curviness and angle of the Daphnia tracks. Observed parameters are compared to normal behavior. The computer screen shows you the graphic desk of the DaphniaToximter. Let me now explain the functions of the graphic desk. The left window shows the living Daphnia in their chamber. The middle picture, the registered tracks, with a different color track for each Daphnia. In the right window you find the parameters as well as the traffic light that indicates the toxic index and instantly informs you about any change in the Daphnia condition. All functions are easily accessible through menus, shortkeys or buttons. The integrated BBE Dienstsprung software analyzes the alterations to normal patterns of movement. Usually the screen shows normal behavior of movement. The traffic light then shows green. Exceeding a certain level of alteration, the traffic light switches to the yellow attention light. While influenced by harmful substances, the behavior of the Daphnia is disturbed and changes the traffic light to red and releases an alarm. The DaphniaToximter can be part of a monitoring station that controls surface waters. Hamburg, one of Germany's largest cities, uses BBE DaphniaToximeters to continuously check the quality of river waters. The Daphnia test is a widespread test to monitor water for traces of harmful substances. The German Institute for Standards prescribes regulations for a static Daphnia test. But where the usual interpretation of Daphnia tests only reflects the mortality rate of the Daphnia, the new BBE DaphniaToximter can detect even extremely tiny traces of toxic substances through interpretation of the smallest changes in the Daphnia behavior. That means a faster reaction to any water pollution and therefore a much safer method to monitor water quality. The quality of water may also be affected by the presence of algae. During past years, numerous reports were presented demonstrating the dramatic toxin production by blue-green algae. A reliable and fast method became necessary to determine the presence of algae in situ. The Flora Probe, a new submersible instrument for algae determination and content measurement, was developed by BBE. This instrument determines different algae groups quantitatively in real time using the fluorescence emission of chlorophyll. The newly developed probe is a submersible fluorometer that measures the intensity of fluorescence emission excited in 5 characteristic wavelength ranges using light-emitting diodes, LEDs. The probe transfers all data online to a personal computer or stores them for further analysis. High sensitivity and a dynamic range enables the Flora Probe to measure fluorescence excitation at extremely low chlorophyll concentrations. Up to 5 different algae groups are analyzed simultaneously: blue-green algae, green algae, diatoms, Dinophyceae and Cryptophyceae. Algae chlorophyll A is excited with light of 5 LEDs. The LEDs are switched alternately by a microcontroller. Fluorescence measurement is a powerful and proven method. Optical emission of fluorescent light is detected even at a low level by a sensitive photomultiplier. Measurement of the pressure enables the calculation of the water depth. Chlorophyll A fluorescence corresponding to the different pigments of the specific algae is recorded. Data may be stored in the probe or sent onto the personal computer. As the Flora Probe is on its way deeper into the water, data is sent online to a computer where the software visualizes the distribution of the different algae classes on a display. Each algae class is represented by a different color. Using this direct and fast method makes the Flora Probe a unique instrument for the early identification of changes in the status of the aquatic ecosystem. The probe is used in the following areas: water control, limnological work, environmental control, research and education, river dam control, ocean research. The presently available methods for determination of the phytoplankton distribution in water often lack the accuracy to achieve a thorough understanding of the role of phytoplankton in an aquatic ecosystem. Also, the typical delay between analyzing a water sample and receiving the final results mostly excludes the use of conventional methods. The BBE Flora Probe assesses algae population with presently unmatched spatial and temporal resolution. The Flora Probe was designed as a sensitive and reliable instrument that is easy to use. The functional and design features already have convinced many users that the Flora Probe is the right instrument. We expect the probe to become an important new instrument in aquatic ecology and for monitoring water resources. We hope to have successfully introduced the new BBE instruments to you, and thank you for your interest. For further information, you are welcome to contact us.